Somewhere in the Pacific Ocean right now, a salmon is swimming toward a river that no longer exists. It has been navigating for 3 years, crossing thousands of miles of open ocean. Using a map encoded in its body before it was born, it will find the exact river, the exact tributary, the exact stretch of gravel where it hatched. Except the river was dammed in 1964, the gravel is under 40 feet of concrete, and the salmon will arrive at the place its body told it to go, and there will be nothing there. Scientists spent decades studying salmon migration and calling it one of the great wonders of the animal kingdom. What they eventually realized is that they had misread what they were watching. This wasn't just migration, it was something more fragile, and something we didn't understand until it was almost gone. To understand what is actually happening when a salmon returns home, you have to start at the beginning, not of the salmon's life, of its memory. When a salmon hatches, it spends its first weeks in the river where it was born. During this window, something extraordinary happens inside its nervous system. The salmon imprints. It memorizes the magnetic signature of that specific location on Earth. The precise chemical cocktail of minerals, sediment, and organic matter dissolved in that water, and it stores all of it at a level deeper than conscious recall. This is not learning. The salmon doesn't decide to remember. The information is written into its nervous system the way instinct is written, automatically, permanently, below the threshold of any choice. Then it leaves, travels downstream, enters the ocean, and for the next 2 to 7 years it lives an entirely different life. And then one day something shifts, a hormonal signal, a change in the water temperature, a cue researchers still don't fully understand, and the salmon turns around. It begins navigating using Earth's magnetic field like a compass, orienting itself toward the general region of its birth river. As it gets closer to the coast, it switches systems. It starts following the chemical signature of its home water, detecting concentrations measured in parts per trillion. That is the equivalent of detecting a single drop of a specific liquid dissolved into 20 Olympic swimming pools. The salmon finds the river mouth, then the tributary, then the exact bend in the stream where it hatched. And it does this after years in the open ocean, after thousands of miles, without ever having made the return journey before. No individual salmon has ever done this trip. The knowledge of how to do it was inherited. Here is where the story changes. Starting in the mid-20th century, humans began altering rivers at a scale and speed the salmon's navigation system had never been designed to handle. Dams, diversions, temperature changes from deforestation stripping shade from riverbanks, gravel beds buried under sediment from upstream erosion, the chemical signatures of home rivers shifting as the landscape around them changed, and the salmon kept coming, because the map inside them said to. Researchers began documenting something they called navigational confusion, salmon arriving at the mouths of rivers and holding there, circling, unable to locate the chemical signal they were built to follow because the signal had changed. Some pushed upstream past the dam and stopped, unable to go further, unable to spawn, dying in place. Others made it to what should have been their spawning ground and found altered gravel. The eggs suffocated. The next generation never hatched. But the deepest problem was not the ones that failed. It was the ones that never made it back at all. Because the imprint doesn't just guide the salmon home, it is also what the next generation inherits. A salmon that returns and successfully spawns passes forward a living memory of that place. The offspring will imprint on that same water. They will return to the same ground. The knowledge of where home is accumulates across generations, refined, reinforced, passed forward in the body. A salmon that never makes it back passes nothing forward. What researchers began realizing is that they were not just watching a population decline, they were watching a library burn, river by river, generation by generation. The accumulated navigational memory of thousands of years of successful return journeys, erased, not recoverable, gone. When people talk about salmon collapse, the conversation almost always goes to the same place: overfishing, habitat loss, climate change. These are real, The data is not in dispute, but there is a layer underneath all of them that almost no one discusses. In the 1990s, researchers began studying hatchery salmon, fish bred in captivity and released into rivers to supplement wild populations. By every obvious metric, hatcheries looked like a solution. The numbers went up. The problem was what was missing from those numbers. Hatchery salmon are raised in artificial environments. They do not imprint on a wild river during the critical developmental window. Some imprint on the hatchery water itself. Some imprint on nothing coherent at all. When researchers tracked their return journeys, they found something that shifted the entire conversation. Hatchery salmon returned at dramatically lower rates than wild salmon. The ones that did return often couldn't locate productive spawning habitat. And in rivers where hatchery fish interbred with wild fish, the navigational precision of the wild population measurably declined within a few generations. The solution had been diluting the very thing it was supposed to protect. The thing that was disappearing was not the salmon. Salmon can be bred in tanks. The thing disappearing was the knowledge encoded in the wild salmon's body. The specific, place-based, generationally inherited memory of where home was and how to get there. That knowledge cannot be bred in a tank. It cannot be restored once the lineage breaks. To understand why this matters beyond the salmon itself, you have to understand what salmon actually are inside a river ecosystem. They are not just fish, they are a nutrient delivery system. Salmon spend years in the ocean feeding on marine life, accumulating mass, absorbing nutrients from an environment a river on its own cannot produce. When they return and spawn and die, and they all die, their bodies decompose in the river. The nitrogen and phosphorus from their marine-fed bodies fertilizes the riverbank. Trees within 150 meters of salmon streams grow faster than trees further away. Bears carry salmon carcasses into the forest and leave the nutrients distributed across a wide radius. The insects that break down the carcasses become food for the next generation of juvenile salmon. The salmon bring the ocean inland, annually, in their bodies. In rivers where salmon runs have collapsed, researchers documented measurable drops in the nitrogen content of riverside soil. Trees grow more slowly. Bird populations that depend on salmon-associated insects decline. The river doesn't collapse, it just becomes less than it was. And it has no way to signal that something is missing. Because the absence of something that used to be there looks, from the outside, like a baseline. The scientists who study this most carefully are not pessimists. They are doing something harder than pessimism. They are working with what remains. In the Pacific Northwest, there are ongoing efforts to remove dams and restore river flow to channels that haven't run freely in decades. The Elwha River in Washington state had 2 dams removed between 2011 and 2014. Within 2 years, Chinook salmon were spawning in sections of river they hadn't accessed in a century. The navigational memory was still there, carried in the lineage of fish that had been spawning in the lower reaches, maintaining some version of the imprint through generations of constrained return. Not every river will recover this way. Many of the lineages are gone. The memory is gone with them. But the Elwha result told researchers something important. The knowledge is more persistent than they expected, and the river is more responsive than the models predicted. What the researchers are careful to say is that the window is not closed, but it is narrowing. Each generation that fails to return is a generation whose knowledge does not get passed forward. The breaks accumulate. They are not sure where that point is. They are trying to find out before they reach it. There is an obvious reading of this story. Humans damaged the environment and the salmon paid for it. That reading is true. But it is not the deepest thing the data is pointing at. What the salmon story is actually about is a kind of knowledge we didn't have a name for until we started losing it. Not learned knowledge, not stored knowledge. Knowledge that lives in a lineage, that exists only as long as the chain of inheritance stays intact, that cannot be written down or preserved or restored from the outside, that is simply present when the line is intact, and simply gone when it isn't. The salmon don't know they're carrying it. They just swim toward home. The question the data leaves open is whether home will still be there when they arrive.